Okay, in the last video I said that if I kind of constrained the internal energy, saying that the change in volume was equal to 0. So what if we ask the question, you have a heat that is transferred into a mass, but the delta V is not equal to 0, then are we still talking about internal energy? Well, you can imagine that if the delta V, if somehow you had heat that flowed into this object, and the heat somehow caused this thing to expand against the pressure of the atmosphere. We know the atmosphere is pushing down on this surface all over the place. Turns out that, of course, the act of this metal expanding to this new volume does work. So there is work done that is equal to basically the change in the pressure times the volume. So if the pressure is constant, the work is equal to P delta V. This is actually equal to the work that is done, the work done by the mass. So no longer do we have just internal energy. We actually have something that we've redefined here now. The enthalpy is equal to the internal energy plus this term right here, or in other words, the change in enthalpy is equal to the change in internal energy plus P delta V plus the work that it does. And this is equal to the MCAT. So what this is saying here is there's a new term called enthalpy that accounts for the internal energy change when you have this heat that is flowing into here, and it also accounts for the work that the volume does against the pressure that is pushing on this device at all, or this mass at all times. So this term right here, enthalpy, is also an energy term, but again, it accounts for two things. It accounts for the internal energy that's changing, and that's reflected in the change in temperature. And it also accounts for the work that this mass does on the environment. So that's the difference between I'm going to try to hear this, the internal energy here, internal energy, and this thing that we're calling enthalpy, which is also a energy term. Now you might ask yourself, why are we bothering with this new term, enthalpy? Well, in a nutshell, almost all of thermodynamics is a gigantic accounting system for energy, and the accounting system is based on what I insist is really the one idea that engineering is about. I mean, the one idea that engineering in the physical realm is about, and that is essentially the conservation of energy. So thermodynamics is essentially accounting for the energy because it's all conserved. And what it's saying, this equation, is that when you have some kind of energy transferred into a mass, that energy is going to be put into changes in internal energy reflected in the change in temperature, and it will be spent on doing work on the environment if the volume changes of this mass. Now normally, really only gases undergo significant enough delta V to have this work term be, anything significant. So oftentimes they collapse this part right here for solids because the change in internal energy is essentially equivalent to the enthalpy change, or the heat that is transferred into there.